Hello everyone. Today we're going to discuss about a recoil velocity of a gun. And what is it about? By definition, the velocity with which a gun moves backward after firing is called the recoil velocity of a gun. We have often seen that during a gunshot, a person get a backward push. And why it is happening? Of course, due to the recoil velocity of this gun on the person. Dear student, let me discuss what is the cause of this recoil velocity. Let me tell you, Newton's third law involves here. During a gunshot, gun exerts force on a bullet, action, and in reaction, bullet exerts equal and opposite force to the gun. This will be the exact discussion point. We're going to see how to derive the formula based on this. We're going to see how to solve the numericals in the same, right? This is one of the major topic keeps on coming in your school exam. Let me see how to derive the formula based on recoil velocity of gun. During a gunshot, if I consider capital M to be the mass of the gun, small m to be the mass of the bullet, small v to be the velocity of the bullet, likewise capital V as the recoil velocity of the gun. So we'll write the same, m as the mass of gun, small m as the mass of bullet, small v as the velocity of bullet, likewise capital V as the recoil velocity of the gun. Now let me find the total momentum of the gun before firing, and that will be equals with 0. Why it is so? Because before firing, we don't have a velocity for gun and we don't have a velocity for the bullet as well. Therefore, the overall momentum of the system gonna be equal with 0. Now let me find the total momentum of the gun and the bullet after firing. To do so, you will multiply the mass of the gun with the velocity of the gun. You're done with the gun. Similarly, you will multiply the mass of the bullet with velocity of the bullet. You're done as well. After that, you add both. Once you add both, you will get the total momentum of the gun after firing to be momentum of the gun plus momentum of the bullet. After that, you apply law of conservation of momentum. Once you apply law of conservation of momentum, accordingly, the total momentum of a system remains conserved. Here you go. Now, shift the momentum of the bullet on the other side, you will get minus. On further solving it, take the mass downstairs as denominator, and here you go, you got your derivation. Let me frame everything again. We have 3 steps involved, student. First of all, you are writing the mass and velocities for the gun and the bullet. Secondly, you are getting the momentum before and after firing. After that, you apply the law of conservation of momentum, and finally, on further simplification, you will get your derivation. Now let me make the use of the formula we have derived. To do so, let me take a question. During a gunshot, if I consider the mass of this bullet to be 20 gram, if I consider its velocity to be 150 meter per second, if I consider mass of this gun to be 2 kg, and let me find out the recoil velocity of this gun. So I will write the same, given mass of gun denoted by capital M, 2 kg, mass of bullet, small m, 20 gram. Now this 20 gram you have to convert in kg. Divided by 1000, you will get 0.02 kg. Next step, write the velocity of bullet, 150 meter per second, and you have to find the recoil velocity. Please mark here the 20 gram of the bullet is converted into kg by dividing it by 1000, and we get 0.02 kg. I will write the same over here. You have, using the recoil velocity minus mv divided by m. Put the given values. For mass of the bullet, you will put 0.02 into, for velocity, you will keep 150, and for the mass of the gun, you're gonna put 2. On further solving it, you will get your answer as 1.5 meter per second. But mark it, you got a negative value. Why it is so? Because negative value shows the direction of the recoil velocity, which is right opposite. Fine. Let me see in the entire system, does it satisfy law of conservation of momentum? And how can we do that? Just find out the momentum of this bullet, find out the momentum of the gun. Right now, we found the velocity to be minus 1.5, right? On multiplying both, you will get 3 kg meter per second, that's the SI unit for the momentum. Multiply both, you're gonna also get the same, 3 kg meter per second. Now listen, what is the beauty of this problem? Does it satisfy law of conservation of momentum? You're gonna tell me exactly yes. How? Because after the gun has been shot, the momentum for the bullet and the momentum for the gun is equal. That meaning it remains conserved. There I go, we did. You have lots of relevant question in your book. Keep solving and cheers.